Hello, good morning. I heartily welcome all the third sem students to Electronics and Communication Department. Myself, MV Gaddi, lecturer in Electronics Department. I am handling for third semester Analog Electronics and Communication Theory subject. It is a 100 marks theory paper and internal 25 marks. Now, analog electronics. Now, today we are going to discuss some basics regarding resistor, capacitor, inductor, and power supply. Resistor, it is the opposition to the flow of current. It is called resistor. Unit of measurement of resistance is ohm. And inductor, it is the unit of measurement is Henry. Then capacitor, which will be stores electrical energy, it is unit of measurement is farad. Current is always measured in ampere, voltage is always measured in volts. Now for analog electronics and communication, the first chapter is what? Power supplies. Power supplies, and in examination it is coming for 30 marks. Second chapter, BJT biasing and amplifiers, total marks 30. Third one, OP-AMP applications, it is for 30 marks. Fourth one, active filters and instrumentation amplifier, 25 marks. Fifth one, wave shaping circuits, 15 marks. Sinusoidal oscillators, 15 marks. Totally 100 marks theory paper. Then the question paper pattern is part A and part B. You have to solve out of 6 units any 5 questions you have to solve. 5 into 6, 30. Then in section B or part B, 10 into 7, 70. 30 plus 70, totally 100 marks. Now course contents, first one is power supply. In this first unit 1, we are going to study what is need for DC regulated power supply, then rectifiers, classification of rectifiers, then efficiency of rectifier, then you are going to studying filter circuits, voltage regulators, etc. Unit 2, BJT biasing and amplifiers. Third one, large signal amplifier. Third one, op-amp and applications. Fourth one, active filters and instrumentation amplifier. Fifth one, wave shaping circuits. Sixth one, sinusoidal oscillators. Mainly we are going to focus on unit 1, power supply. Need for DC power supply. Power supply is usually required for electronic equipment. Almost all electronic equipments, any devices will work on DC power supply. The aim of a DC power supply is to provide the required level of DC power to the load using an AC supply at the input. Different applications require different attributes, but more than not these days, DC power supplies provide an accurate output voltage. This is regulated using electronic circuitry so that it provides a constant output voltage over a wide range of output loads. The output of unregulated DC power supply is affected by the following factors. AC to DC conversion, it is called rectifier. It is unregulated power supply. That is, it is unregulated power supply. We have to regulate it. Regulate means we have to remove AC components. Then the need of power supply will be required for almost all in almost all electronic devices are purely DC. Then the first point, poor regulation. Regulation means to control. The output voltage is affected by the magnitude of current drawn from the supply. That is poor regulation. Variations in AC supply. The DC output varies due to the fluctuation in the AC supply voltage. The output will be fluctuating means it will be varying. Then variations in temperature. As performance of semiconductor device is dependent on temperature, the output DC output also varies. These variations in DC output voltage may cause inaccurate or erratic operations of many electronic devices. To overcome these problems, the regulated DC power supply is needed. Unit 1, power supply. Why the need of DC power supply is required for different application purposes. We are going to convert AC voltage to purely DC voltage, and that is unregulated DC supply. We have to what? We have to regulate it. Regulate means we have to getting constant output voltage will be required for different applications. Then we have to regulate it means we are going to using some filter circuits. We are going to remove some AC. DC is there, pure DC, but small amount of AC will be there, that we are going to remove it. Poor regulation. The output voltage is affected by the magnitude of current drawn from the supply. That is called the poor regulation. Variations in AC supply. The output DC voltage is varying if the input voltage is changes, that is fluctuations will be there. That time we are using what? Stabilization will be required. Stability will be required to fix the DC voltage. Variations in temperature. Semiconductor devices are depending upon the what? Negative temperature coefficient. If temperature increases, their resistances will be decreases. These variations in temperature will be there. But for power supply, we are using diode. You already know what is diode. In my first YouTube lesson, you have studied what is resistance, what is inductor, what is capacitor. Similar way, the function of the diode is to what? It will be input we are going to AC, but it is a purely DC device which will be operates for the DC voltages only. Then second, DC power supply block diagram. First one, transformer, rectifier, filter, regulator, load. AC input is given to transformer, output AC voltage to DC voltage. It is converted. Rectifier is a device which converts AC to DC voltage. That is called the rectifier. Then that output will be given to filter circuits. Filter which will be removes unwanted AC. Okay. Regulator which will be regulates or controls the DC voltages. Then that is given to the load resistance. We are getting constant DC voltage. Pure DC voltage will be represented by a straight line. Then the pulsating DC will be given by the only half waves. Then you already studied what AC. AC means alternating current which will be changes its polarity continuously. DC voltage which has got only one direction, positive. Transformer input Phi sine of omega t. Transformer is a electric device which converts AC to, that is AC input we are going to getting AC output voltage. That is, transformer may be step up or step down. Step up means increases output voltage, step down means decreases output voltage. Here you are using ordinary, that is simple transformer. The output will be given to rectifier. Rectifier which converts AC to DC voltage, that is called the rectifier. Filter which will filters unwanted AC present in DC separation, that is called the filter. Regulator which controls the DC voltage. The output is given to what? Output is given to load. Transformer. The input transformer is used to transform the incoming line voltage down to the required level for the power supply. Typically, the input transformer provides a step down function. It also isolates the output circuit from the supply. Rectifier, the power supply rectifier converts the incoming signal from AC into pulsating DC. Either half wave or more commonly full wave rectifiers may be used, as they make use of both halves of the incoming AC signal. That is, different types of rectifiers are there: half wave rectifier, full wave rectifier. Filters. The output of rectifier consists of AC ripples, which are also undesirable for electronic circuit. To remove such ripples, filters are used. Regulator. The stage of the power supply takes the smoothed voltage and uses a regulator circuit to provide a constant output virtually regardless of the output current and any minor fluctuations in the input level. First block transformer, second block rectifier, filter, regulator. Transformer converts AC to AC, depends upon step up or step down. Here there is no question of step up or step down. Then rectifier DC. Rectifier is a circuit which converts AC to DC. The main component of rectifier is diode. Diode is a DC device. Important parameters of rectifier. First one, ripple factor. Ripple factor is defined as the ratio of RMS value of AC component to DC component. Ripple means unwanted AC present in DC. Then efficiency of rectifier is defined as the ratio of output power to the AC input power. It is denoted by eta, Greek alphabet. Eta equal to DC output power divided by DC input power, or efficiency is given by DC output power to the, here DC efficiency of a rectifier is given by like this: DC output power divided by AC input power. There is a small correction, you have to correct it. Then one more definition, peak inverse voltage. It is defined as maximum reverse voltage that a diode can withstand. It is called peak inverse voltage. Ripple frequency, it is F0. It is defined as the frequency of rectifier output. Definition of rectifier: rectifier which converts AC to DC. The main component of rectifier is a diode. Diode is heart of the rectifier. It is also plays a important role. Important parameters of rectifier: ripple factor, the unwanted AC present in DC, that is called the ripple. This ripple can be removed by using some other circuitry. Then efficiency is given by DC output power to the AC input power. Then peak inverse voltage, it is defined as the maximum reverse voltage that a diode can withstand. Reverse voltage means if diode is connected in the reverse bias condition, that is peak inverse voltage. Ripple frequency, it is defined as the frequency of the rectifier output. Now, types of rectifiers. First one, half wave rectifier. Second one, full wave rectifier. Circuit diagram shows one transformer, one diode, and load resistance. The input AC voltage to be rectified is connected to the primary input of one transformer. At the secondary, the diode is connected, load resistance is connected. For any circuit diagram explanation, first circuit diagram is very important concept. Then construction, that is how the components are connected in a neat manner. Then working circuit details or circuit operation, that is if we switch on the circuit, how the current will be flows, what is the effect of the on diode, load resistance, etc. That is the circuit details or circuit operations. Half wave rectifier consists of a diode and step down transformer. Here we are going to using step down transformer which will be lowers AC to DC, which is used to decrease the input voltage to the required level as shown in figure A. During positive cycle of input AC, the diode is forward biased and acts as a closed switch. That is secondary and we are going to connecting one diode at the positive half cycle. Secondary transformer one end becomes positive, another end becomes negative. That times diode will be acting like a closed switch, that is current will be flows through load resistance. During negative half cycle, one end of the transformer upper will be negative, bottom will be positive. That time it is the reverse bias condition. That time diode is not conducting. Only for the positive half cycle the diode is conducting as shown in figure. One more circuitry, full wave rectifier. Here the diode we are using full wave rectifier, that is center tapped rectifier. For secondary winding, we are going to tap one middle point and we are going to connected one load resistance. Here two diodes are connected for one end of the secondary, another end of the secondary, and one center tap we are going to connecting one load resistance. Then the waveforms as shown below figure. During positive half cycle, diode D1 is forward bias condition, then it will be conducts from D1 to load resistance. Okay, D2 will be off in when it is at the positive half cycle. During negative half cycle, opposite one, D1 is of D2 is on, then the waveform negative half cycle also it will be conducting. The waveforms will be shown in below figure. Full wave rectifier consists of two diodes, step down transformer, which is used to decrease the input voltage to the required level as shown in figure. During positive half cycle of input, the P1 terminal of transformer becomes positive and P2 becomes negative. Therefore, D1 is forward biased and acts as a closed switch, whereas diode D2 reversed biased and acts as an open switch. Hence, current flows via D1 through RL. During negative half cycle AC input, P1 terminal of transformer becomes negative and terminal P2 becomes positive. Therefore, D2 is forward biased and acts as a closed switch, whereas D1 is reverse biased and acts as a open switch. Hence, current flows via D2 through RL. The output of waveform is shown in below figure. During positive half cycle, one diode is conducting, another diode is reverse biased. During negative half cycle, upper diode is off, below diode is on. That is, both in half wave rectifier, it will be conducts for only for positive half cycle of AC. Here, full wave rectifier during positive half cycle, that is during positive half cycle also conducting one diode, and during negative half cycle another diode is conducting. This is regarding full wave full wave rectifier. Next one, that is some derivations are there. We have already studied, that is RMS values, root mean square, then DC values, etc. Now, after this, we are going to derive what is ripple factor, what is efficiency, etc. in next my class.